Welcome student. In this class we study the different terms used in the Theodolite survey. So terminology. Okay. So first we study the axis. So there are some important axes in this Theodolite survey. So first axis is the vertical axis. So this axis, these are all imaginary axes, you can't see, they are invisible. So first important axis is vertical axis. So you can define like this: vertical axis is the axis about which you can rotate the instrument in horizontal plane like this. So here one imaginary axis about which you can rotate the instrument in horizontal plane. That is the vertical axis. So if you suspend a plumb bob here, so then that is the vertical axis of the instrument. So second one is horizontal axis. Horizontal axis, or it is also called Trunnion axis, that is here. So you can define like this: horizontal axis or Trunnion axis is axis about which you can rotate the telescope in vertical plane. So like this. So this is called horizontal axis. This axis is called horizontal axis. Then third is line of sight. Line of sight means, so here you are having the objective lens is there. Here you have the eyepiece lens is there. Then here near to eyepiece, there is a diaphragm. There is a diaphragm here. Diaphragm contains two crosshairs like this. One vertical crosshair and another one is horizontal crosshair. So vertical horizontal crosshair intersection and optical center of the objective. So the line joining those 2 points and their continuation is called line of sight. Line of sight, it is a line joining two crosshairs and optical center of the objective and its continuation. That is called line of sight. Vertical axis, horizontal axis, line of sight. Next, bubble tube axis, axis of bubble tube. So this is the bubble tube. So this is longitudinal face of the bubble tube. This is the transverse face. So along the longitudinal face, that means along the length of the bubble tube, tangentially, if you draw a line at a center, then that is the bubble tube axis. So here, this is the bubble tube axis. Okay. So if you draw a bubble tube axis here, then that is called plate level axis. Similarly, if you draw a bubble tube axis at here, then that is called altitude level axis. So like that, axis of plate level, axis of altitude level. So like that, we have the 5 fundamental axes. So one is vertical axis about which you can rotate the instrument in horizontal plane. Second one is horizontal axis, axis about which you can rotate the telescope in vertical plane. Next, line of collimation, line of sight. It is the line joining intersection of two crosshairs at diaphragm and optical center of the objective and its continuation. That is the line of sight. Then plate level axis, it is the line at the center of the bubble tangentially in the longitudinal direction of the plate level. Similarly, altitude level axis. So like that, we have the 5 fundamental axes of the theodolite. So some other terms are, first one is centering. Centering means setting the instrument exactly over the station point. So station point means, in station point there may be an arrow, or there may be a peg, or just a mark on the ground, nail mark or chalk mark. So then setting the instrument exactly over the station point using a plumb bob, or here plummet is there, looking into the plummet. So or suspend a plumb bob, or at least drop a stone, then that is the centering. That process is called centering. Next, transiting. Transiting means the rotation of the telescope. So now line of sight is like this, in this direction. So now I need line of sight in opposite direction. I have to reverse. Then the process of rotating the telescope in vertical plane like this through 180 degree. So here to here means 180 degree. Process of rotating the telescope in vertical plane through 180 degree is called transiting. So transiting is also called reversing or plunging. So what we are doing in transiting? In transiting we are reversing the line of sight. So it's very important term, transiting. Next, swinging. Swinging means rotating the telescope in horizontal plane like this. This is called swinging. If you rotate towards right hand side direction like this, then this is called right swing. Clockwise direction, right swing. Like this, anti-clockwise direction or left hand side direction, left swing. So right swing, left swing. So there are two types. Okay. Next, now whenever you take the observation to measure the angle, then vertical circle, if the vertical circle is left side, left face of the observer. So I am taking observation like this. So vertical circle is my left side. Then the observations what I am taking, so they are called face left observation. So face left, it is referring to vertical circle. If it is vertical circle is left side, then face left observation. Similarly, so when vertical circle is right side, then face right observation. So face left, face right. So now it is face left, left of the observer. Now it is right side, right, face right observation. So like that, face left, face right. So next, changing face. Changing face means, so now it is face right. Face right to face left, you have to convert. So how to do that? You have to change from face left to face right. So first you transit the telescope, then swing like this. So by transiting and swinging, you can change the face from face left to face right or vice versa, face right to face left. So this process is called changing face. Face left observation, face right observation, changing face. Then the last two terms are, in some theodolite on the telescope there will be a bubble tube. Then if it is face left and bubble up, face left, bubble on top of the telescope, bubble up, then that is called telescope normal. Telescope normal. When you transit, so bubble will come down, vertical circle right side. So this is face right, bubble down, face right, bubble down. Then that is called telescope inverted. Telescope normal, telescope inverted. So these are the different terms we use in the theodolite surveying. Okay, thank you very much. So now we will study some important operations. Okay, so this is the telescope. You can rotate the telescope in vertical plane like this. So when you rotate the telescope in vertical plane, so inside the vertical circle, so vertical circle is there as well as two verniers are also there. So which will rotate? This is very important. So when you rotate the telescope like this, so inside this vertical circle will rotate. Vertical circle will rotate with the telescope. This is very important. And here there is a vertical clamp. If you clamp this vertical clamp, you can't rotate the telescope. Unclamp, you can rotate. Then to fix this telescope in any desired position, then there is a vertical tangential clamp. So vertical main clamp, vertical tangent clamp or fine adjustment clamp. And there is a focusing screw. Using this focusing screw you can focus the object. So then coming into this, so vertical circle is used to measure vertical angle. Okay, so here 0, 0 are there. Here you have the two verniers. Those verniers are called C vernier and D vernier. AB are here. AB verniers, CD verniers. So in C vernier and D vernier, you can keep the reading exactly 0. When C vernier and D vernier reads the reading 0, means then this line of sight is exactly horizontal. When in vertical circle C and D verniers are 0, then this line of sight is exactly horizontal. Then you can use this instrument as a dumpy level to take the staff reading. You can do leveling also. Okay, this is one advantage of the theodolite. But dumpy level you can't use as a theodolite. But theodolite can be used as dumpy level also. How? By keeping telescope exactly horizontal. C and D vernier reading 0, 0. So then another important thing is here in horizontal circle, it is also graduated from 0 to 360 degree. Continuous graduation is there. But here it is divided into 4 quadrants, 0 to 90, 0 to 90. So if you keep telescope like this, means it is in 90 degree direction, 90 degree it is. Okay. So here in horizontal circle it is graduated completely in clockwise 0 to 360 degree. So 0, 90, 180, 270, 360. So like this. So it is continuously graduated. So here you have the two verniers, A vernier and B vernier. So A vernier it is near to 0 end, B vernier is near to 180 end. So like that you have the two verniers. And very important thing is we have the two clamps here. So this is upper clamp, this is lower clamp. So now we will study the operation of these two clamps. When both clamps are clamped like this, upper clamp, lower clamp, both are clamped, then you can't rotate the instrument. When lower clamp is clamped, you can rotate the instrument. But here the arrangement is like this: horizontal circle and verniers both are locked because upper clamp is clamped. They are clamped, and you can rotate the instrument about the outer axis. Means there is no relative movement between the horizontal circle and two verniers. So they are rotating in a attached manner only. There is no movement between those two. Both are rotating at a time. But when you clamp the lower clamp is clamped, upper clamp is released, unclamped. Now if you rotate the instrument, now the verniers are only rotating, not the horizontal circle, because horizontal circle is clamped by lower clamp. Upper clamp is released, means verniers are now free to rotate. So this is the very, very important operation or the arrangement you have to remember. Upper clamp, lower clamp. When you have to use upper clamp, when you have to use lower clamp. When both clamps are clamped, there is no movement. When lower clamp is released, then there is a movement, but horizontal circle and verniers, they are clamped. When lower is clamped, upper is unclamped, then if you rotate, then there is a relative movement between horizontal circle and the vernier. Vernier will move now. So this arrangement must be very clearly you should understand. So thank you very much.